Most software projects don't fail suddenly. They drift, they decay, they accumulate invisible risk until one day everyone realizes this isn't going to work. And by then it's expensive. Today we're going to count down the 10 warning signs that a software project is heading toward failure. Not obvious disasters, not dramatic explosions, but subtle structural signals that experienced engineers learn to recognize early. If you're learning software engineering, not just programming, this perspective matters. Let's start at number 10. 10. The team talks about solutions, not problems. This is one of the earliest signs. Someone says, we should build a dashboard. We need to move to microservices. Let's integrate AI. Notice what's missing? The problem. What user pain are we solving? What metric are we improving? What constraint are we addressing? When teams jump directly to solutions, they anchor themselves to assumptions, and assumptions harden quickly. Strong teams obsess over problem clarity. Weak projects obsess over implementation ideas. If no one can clearly articulate who the user is, what pain exists, why now, what success looks like, the project is already unstable. 9. Requirements live in people's heads. If you ask 3 stakeholders what the product is supposed to do and you get 3 different answers, that's a red flag. When requirements are vague, unwritten, constantly reinterpreted, or we'll figure it out later. You are not building software, you are building misunderstandings. This is something we talked about in more depth in our earlier breakdown of failure patterns. Projects fail in conversations long before they fail in code. If acceptance criteria don't exist, you can't measure done. And if you can't measure done, scope expands forever. 8. Deadlines are fixed, but scope is not. This is one of the most dangerous combinations in software. A launch date is announced, marketing prepares, leadership commits publicly, but features continue to grow. Just one more small addition. Can we also add reporting? Support mobile too. Complexity doesn't grow linearly. It compounds. If the deadline is immovable and scope keeps expanding, something has to give. Usually it's testing, refactoring, documentation, architecture quality. That creates hidden instability, and instability compounds silently. 7. No one owns the system, end to end. When something breaks, listen carefully to what people say. If you hear, that's not our component, that's another team, that's handled by ops, you may be seeing fragmented ownership. This is one of the most consistent patterns in large-scale failures. In the healthcare.gov case study, multiple vendors and agencies were involved. Fragmented responsibility contributed to integration chaos. In any organization, startup or enterprise, if no one owns the system holistically, reliability becomes accidental. Successful projects have clear technical ownership, clear product ownership, clear operational ownership. Ambiguity here leads to slow decisions and unresolved risks. 6. Testing is always next sprint. Under pressure, testing is the first thing to shrink. You'll hear, we'll add tests later. Let's just get it working. We don't have time for integration tests. Testing isn't just about correctness, it's about confidence. When automated tests are weak or non-existent, refactoring becomes scary, releases become stressful, bugs multiply, developers hesitate to make improvements. Eventually, velocity drops dramatically. What looks like speed in the short term becomes paralysis in the long term. 5. Architecture decisions aren't written down. Ask the team, why did we choose this database? Why are we using this framework? Why is this service synchronous? If the answer is, I think that's just how it evolved, you may be looking at architectural drift. Decisions without documentation get forgotten, get relitigated, get contradicted, get misunderstood by new engineers. Architecture needs shared memory. Without it, systems slowly lose coherence. 4. Feedback is ignored. Users complain. Metrics show low engagement. Support tickets increase. But internally, the roadmap continues unchanged. This is a classic failure mode. Sometimes teams ignore feedback because they're too invested in the current plan, they've already spent too much effort, they fear rework, or leadership resists change. But reality doesn't negotiate. If the product doesn't solve a real problem, no amount of clean code will save it. 3. Communication is reactive, not proactive. Healthy teams surface risk early. Unhealthy teams hide it. If status updates sound like everything is on track, right up until the moment things explode, there's likely a communication problem. Warning signs include no clear risk log, no regular demos, no shared roadmap visibility, no postmortems after issues. Software projects are communication systems. When communication weakens, alignment drifts, and drift accumulates quietly. 2. The system feels fragile. This one is subtle. Developers start saying, "Don't touch that module. That part always breaks. Deployments make me nervous." When engineers are afraid of their own system, technical debt has likely accumulated. Fragility means small changes cause unrelated failures. Build times grow, debugging becomes slow, onboarding takes longer. At this stage, the project may still look successful externally, but internally, structural decay has begun, and decay accelerates over time. 1. Leadership treats software like construction. This is the most fundamental warning sign. If leadership assumes software works like building a bridge, fixed blueprint, fixed timeline, fixed cost, minimal change, they are misunderstanding the nature of software. Software is exploratory, requirements evolve, edge cases emerge, integration reveals unknowns. When leadership demands certainty in an uncertain process, teams respond by overpromising, hiding risk, compressing testing, cutting discipline. That creates a failure loop. Unrealistic expectations leads to shortcuts, leads to instability, leads to delays, leads to more pressure, leads to more shortcuts. This is how many projects collapse. The pattern behind the signs. Notice something. Most of these warning signs are not about code quality. They are about alignment, ownership, scope control, communication, incentives, discipline. This is exactly what the shape of software is about. Software engineering is not just syntax. It's understanding how real-world systems are planned, coordinated, built, and maintained. If you learn to see these structural signals early, you can raise concerns sooner, ask better questions, protect engineering discipline, reduce risk before it compounds. That's the mindset shift from programmer to engineer. Final thoughts. Software projects rarely fail because developers can't code. They fail because complexity is unmanaged. They fail because communication erodes. They fail because scope expands silently. They fail because no one protects structure. If you're working on a project right now, ask yourself, how many of these signs are visible? And if even one is present, what can you do to reduce the risk? If this video helped you think differently about software projects, click like. It genuinely helps the channel. If you want more deep dives, case studies, and structural breakdowns of how real software systems succeed or collapse, subscribe to The Shape of Software. And if you want a structured next step after this, I've linked a beginner-friendly software engineering learning path on Coursera in the description. It walks through programming foundations, workflows, and how real projects operate, without having to guess what to learn next. Now, I'm curious, which of these warning signs have you seen in real projects? Leave a comment below. Thanks for watching.